Hi. As we all know, the advances in technology have changed our lives immensely, especially our means of transportation. Every day, we are surrounded by hundreds and thousands of vehicles, such as cars, trucks, subways, buses, trains, and much more. They help us travel from point A to point B. So what do we have in common? We both need fuel to work. Our fuel, as in water, and their fuel, as in gasoline. In this video, I'll be talking about where hydrocarbons are from, how chemistry applies to them, the effects on people and the environment, and how technology is implemented to minimize these negative effects. As you can see, gasoline first originates from crude oil, also known as petroleum. The crude oil contains various lengths of hydrocarbons. A hydrocarbon is a compound that is made out of hydrogen and carbon. As the length of the compounds increases, the boiling point increases as well. Separating the hydrocarbons by length is a process called distillation. This process occurs in oil refineries. This video diagram shows a simple process of distillation. I won't go too in-depth with hydrocarbons, because that is not my topic, but let's move on. CH4 through C4H10, methane, ethane, propane, and butane are gases at room temperature. C5H12 through C7H16 are clear solvents called naphthas, commonly found in quick-drying products. Gasoline is a blend of hydrocarbons ranging from C7H16 heptane to C11H24 undecane, but consists mostly of octane, C8H18. Have you ever wondered, why is there numbers on the gas pump? Well, that is the octane rating of the gasoline. Octane rating indicates the amount of octane present in the fuel as a percentage. Octane is the dominant compound in gasoline because octane is more susceptible to compression. It will not cause spontaneous ignition, which will cause damages to the engine of the car or vehicle. So, the lower the rating, the higher likeliness of spontaneous combustion. But the higher the rating, the more expensive for the fuel. There is no such thing as complete combustion, so let's pretend we live in a perfect world. In a complete combustion, which means the gasoline, let's assume octane reacts completely with oxygen to create only carbon dioxide and water. No byproducts. So the balance equation is listed below. Well, okay, back on Earth, no more perfect world. Incomplete combustion, which means the combustion does not react completely. Maybe because there is too little fuel or oxygen. So CO2, carbon dioxide, CO, carbon monoxide, and H2O, steam, is formed. But where does the nitrogen oxide come from? Well, it's formed under high pressure and temperature conditions, like in an engine. Also, and I almost forgot, hydrocarbons, which are left over and partially burned after the reaction. One of the byproducts of incomplete combustion is CO, carbon monoxide, which is produced when air-to-fuel ratios are low during combustion. CO is often called the silent killer because it is odorless, tasteless, and colorless. Once it enters the body through inhalation, the carbon monoxide combines with a hemoglobin to create carboxyhemoglobin. Hemoglobin is the protein which transports oxygen to the body. The carbon monoxide replaces the oxygen because the bond between the carbon monoxide and hemoglobin is 200 times stronger than oxygen. Since gasoline is made up of different lengths of hydrocarbons, leftover or partially burned hydrocarbon appear after incomplete combustion. Benzene, C6H6, is often found during the distillation process. Benzene is located in most solvents, gasoline, cigarettes, and more. High levels of exposure will cause cancer, weaken bones, impair blood cell maturation, and possibly death. Another byproduct created with incomplete combustion is nitrogen oxides. They are created when gasoline is burned under high pressure and high temperatures. It comes in different forms. NOx. Nitrogen oxides form acid rain, slows plant growth, is one of the causes of global warming, and when combined with other compounds, they form toxic chemicals. Catalytic converters is a bulky device near the exhaust pipe of a vehicle. It is used to reduce negative effects caused during an incomplete combustion. The catalytic converter does three things. It oxidizes carbon monoxide to carbon dioxide, reduces nitrogen oxides to nitrogen and oxygen, and oxidize unused hydrocarbons into carbon dioxide and water. Also, hybrid cars and electric cars have replaced the need to consume gasoline to operate. It is now time for the quick review. Gasoline is a blend of C7H16 heptane to C11H24 indecane, but consists mostly of octane, C8H18. Octane reading of gasoline indicates the amount of octane present in the fuel as a percentage, and the formula for incomplete combustion is listed below. Exposure to high levels of carbon monoxide and benzene will cause nausea, unconsciousness, and death. Nitrogen oxides, which is created when gasoline or other fuels are burned at a high pressure and high temperature environment. Greenhouse effect occurs when gases which are located in the atmosphere absorb thermal radiation from the sun and reflect it back towards the surface of the earth. We are heading towards the end of the lesson, but wait, here are some fun and random facts about gasoline. A gallon, which is 3.79 liters of gasoline, contains about 132 million joules of energy, or 3 36,650 watt hours. If we ran on gasoline and we drank 1 gallon of it, it would contain about 31,000 food calories. That would be the same as eating 110 McDonald's burgers. 1 liter of gasoline is about 23.5 tons of long decayed organic matter. Well, wasn't that a well spent 10 minutes? I hope you enjoyed this video. Citations and references are on the drop down box below. Please leave a comment. Please give me a thumbs up or a thumbs down. And don't forget to subscribe.